For number 6, we are going to test the hypothesis listed here using the p-value approach. And first, we're going to check this requirement. And so n, it's the number of things in our sample, and then times the proportion that's in the null hypothesis, which is 0.9, and then multiply by 1 minus that. And I'll use Excel here as my calculator. And so if I do that multiplication, I get 22.5 back, which is greater than or equal to 10. So we verified that. And now I'm going to use technology to find the p-value. I'm actually going to start by doing this in Excel, and then I'll move on to StatCrunch, and I'll rely heavily on StatCrunch throughout the rest of this video. But doing it in Excel, you need the point estimate for your sample here. So 230 out of 250, that's the proportion of our sample, which is 0.92. 230 divided by 250. And then you get the standard error for your sample by doing the square root of our null hypothesis here times 1 minus it. So 0.9 times 0.1 divided by the sample size. So the square root of that. And I'm going to use those two values. That's my things I'm going to plug in here and let Excel do all the work. So normal distribution. This is our value for our sample, our point estimate, 0.92. Our null hypothesis, the standard error, and then we hit true. And that Excel gives you back the probability of being at 0.92 or anywhere further to the left. So if you want to go further to the right, you have to do 1 minus that. And so I do that, and I get 0.1459. That's the probability of getting a sample back that has a point estimate of 0.92 or anything larger. And I want to do larger because our alternative here is greater than or larger. So this value, 0.1459, that's larger than our alpha of 0.05. Anytime you get a p-value back bigger than alpha, we do not reject the null hypothesis. So jumping that same thing in StatCrunch, go to Stat. We're doing proportions here. We have one sample, and we have the summary data. There were 230 successes out of the 250 in our sample. 0.9 was our null, and we're doing greater than. And when we hit compute, StatCrunch runs all that calculations behind the scenes and gives us that same p-value. Again, this is larger than alpha, so we will not reject the null hypothesis. So number 7, again, testing a hypothesis using the p-value approach. And first, we're going to verify this requirement. And so our n, the number of things in our sample, multiplied by our value here for our null hypothesis, and then multiplied by 1 minus that same value. And we want to make sure that's greater than or equal to 10, and it is. And then we're going to use technology to find the p-value. So jumping into StatCrunch, we're doing proportions, one sample, and we have the summary data. And our summary data tells us 72 successes out of 150. And we got to enter in our null hypothesis, 0.54. And our alternative is a less than. So make sure we put a less than there. And then we're going to want to hit compute at the bottom. And it gives us the p-value, the probability of getting back a sample that has 72 out of 150 is 0.48. So it gives the probability of getting back a sample that's at 0.48 or even further to the left than, even further less than. It has this probability right here. And so we need to compare this to our alpha. If this is less than alpha, we reject. If it is greater than alpha, we do not reject the null hypothesis. And our alpha here is 0.05. This 0.07 is bigger than 0.05, so we do not reject the null hypothesis. For number 8, we have a similar type of problem to 6 and 7, but we have a story going on here, some context behind the numbers. And so the gist of it is that there's a new drug out, and that for similar drugs, 2.1% of patients complain of flu-like symptoms. So we're going to see if there's evidence that this new drug, that more than 2.1% of its users experience flu-like symptoms. So we gathered a large sample and saw how many people out of that sample complained of flu-like symptoms, and we're going to see if we can verify that it's more than 2.1% or not. So I'm actually going to start just here with the null and the alternative hypothesis. Our null is that this new drug is going to have the same proportion of people with flu-like symptoms. So as a decimal, 2.1%, write that in. And then our alternative, which we're trying to check for, is if it's actually something greater than that. And maybe if it's something greater than that, the company is not going to produce it, or the FDA won't allow it to be on the market or something. So that's what we're checking for to see if it is greater than 2.1%. So first, let's run this check to see if we are greater than 10 when we take the number in the sample and multiply by our null hypothesis. So using Excel as my calculator, type in the sample size, multiply by that null value, and then 1 minus that null value. And we're checking to see if that's greater than or equal to 10, and it is. And the other things that we want to check, that the sample size is less than 5% of the population size. Well, 894 people is definitely less than 5% of the people who will take a drug. It will be distributed to the entire country, if not the entire world. So that's definitely less than 5% of the population. And we're assuming that this is a random sample in this clinical trial. So since we've met all those requirements, the requirements for running a hypothesis test are satisfied. So those three things check off. We have our null and our alternative set up here. So let's jump into StatCrunch to get this test statistic and also do the p-value. And so what I did here, I guess let me go back to the beginning. In StatCrunch from the beginning, go to Stat, Proportion Stats, one sample with summary. So here, success is actually having the flu-like symptoms. We had 23 out of the 894. 2.1% as a decimal, and we're checking to see if this new drug has more than that. So when you hit compute, StatCrunch does all the calculations for you. This is our test statistic here, which would be 0.99 when rounded to 2 decimals. And the p-value for that test statistic would be 0.1621. And so going with the p-value approach, if this is greater than alpha, we do not reject the null hypothesis. If the probability of getting a sample like we have here, is less than alpha, that's when we reject the null hypothesis. So we need to look at what our alpha is. And we have 0.05 for our significance level. Alpha equals 0.05. And so that helps us get our conclusion here. Let me pull it up in the screen. Since the p-value is greater than alpha, we do not reject the null hypothesis. And so what that means is we can conclude there's not sufficient evidence to accept the alternative, which the alternative was stating that more than 2.1% of users experienced flu-like symptoms. For number 9, working through another story problem with proportions. In this example, we're seeing if people's opinions have changed over time. So several years ago, 44% of patients who had children in grades K through 12 were satisfied with the education. We want to see if that satisfaction level has changed. So our null is that the proportion satisfied is exactly the same as what it was. And our alternative, since we're just looking to see if it's changed, gone up or down, is a not equals to that null hypothesis. And so now we're going to use technology. So we're doing proportion stats, one sample with the summary data. So type in the number of successes, people who were satisfied out of the total survey, and the number of people in the survey. And we actually want to build a confidence interval in this problem. So we select our level of confidence, and we're going to hit compute. So it gives us then the lower and the upper bounds of our confidence interval. And so we're going to use this confidence interval to decide whether we can reject the null hypothesis and accept the alternative, or if we have insufficient evidence to reject the null. And the way we do that is we just see if that value lies within the confidence interval. And 0.44 is in between our lower and upper bound. And so we don't have enough evidence to reject 0.44 because it's in our confidence interval. And that's what we're saying down here for our conclusion. The interval contains our null hypothesis, so there's insufficient evidence to reject the null, and rejecting the null meant that the parents' attitudes toward the quality of the education had changed. So there's insufficient evidence that the parents' attitudes have changed. So number 10, again, talking about hypothesis tests, you always have a null and an alternative. For this question, we're really focused on the p-value and what exactly that means and whether it causes us to reject the null hypothesis or not. So in this example, we have a p-value of 0.31. As a percentage, that would be 31%. And let me pull up a picture here in StatCrunch. I'm going to pull up a calculator here. It's got a good visual. Notice our alternative is greater than, so I'm going to switch that to greater than. And 0.31 or 31%. We get this picture here that shades in 31% of the distribution. And so the sample that we just gathered, that the researcher would have gathered, has a test statistic right here on the edge of the shaded region. And the p-value is 0.31, 31%, because that indicates that 31% of the time we get a sample as extreme as the one we just gathered, or even more extreme, even further into the tail and farther away from the center of the distribution. And so in terms of, percentages is out of 100. So the way this question is actually worded here, for a p-value of 0.31, we expect results at least as extreme as the test statistic from our sample, 31 out of 100 samples, because that's 31% of the time. And so 31% is not unusual. Typically, the cutoff for unusual is 5%. That's why 5% is such a common value for alpha, our critical value. But 31% is not unusual, and anytime we have an event that's not unusual, we're not going to reject the null hypothesis.